So we want to look at the conjugate metric tensor, and we consider the determinant of Gij, whose value we can denote by G. And suppose that G, the capital G, Ij, is the cofactor, and here I want to use not Gij, this one. I want to use Gij, so that is a correction there. And because Gij, small gij, is the metric tensor, then the cofactor Gij should be equals to Gji. These two would be equal. Now, we want to look at the normalized cofactor, which we shall denote by Gij, and this is defined as 1 over G. G is the determinant, multiplying by the cofactor. So that's a normalized cofactor. And I want us to do an example. You are given the effort to hide the normalized cofactor, hide Gij. These are the normalized cofactors in spherical coordinate system. In spherical coordinate system. Now we had seen that in spherical coordinate system, the matrix can be expressed as dr squared. Let me use x1 squared plus r. Sorry, I'm making the same mistake. So we have the spherical coordinate system. We have x1 squared dx2 squared plus x1 sine of x2 squared dx3, so that we can write the matrix Gij as having the components 1, 0 there, and 0 there, then 0, and x1 squared, and then 0, 0, and x1 sine of x2 square. These are the components there. So that G11 is equals to 1, G22 is x1 squared, and G33 is x1 sine of x2 squared. So now we want to find the determinant of this, this matrix. So the determinant of this matrix, which we are going to call G, which is equals to the determinant of Gij, because these elements are 0. When we are taking the determinant, we take the element here, we multiply by the cofactor, which is the determinant of this matrix here, obtained by removing the first row and first column. Then we take the next element and do the same, the next row. Because these are 0, then we shall just take 1 and multiply by the cofactor. The determinant obtained by removing row 1 and column 1. So we have 1 times x1 squared times x1 sine of x2 squared. This is the determinant. This is the determinant of that matrix, which is G. So now the cofactor, when we write the cofactor of the cofactor G, 1, 1, the cofactor of the element 1, 1 here, we remove the first row and the first column, then we take the determinant of this 2 by 2 matrix now. If you take the determinant of this 2 by 2 by 2 matrix, then obviously you will get the product of the elements in the diagonal because the others are 0. So that in this case, this will be x1 squared times x1 sine of x2 squared. So the normalized cofactor of G11, which we shall denote by G11 here, will be 1 alpha G times G11. And what is G? We have G here. So G is x1. So we can see that G, small g, the determinant, and the cofactor are basically the same. So we are dividing the same quantity. So we shall be dividing x1 squared times x1 sine of x2 squared by the same x1 squared times x1 sine of x2 squared, and the result is equals to 1. When we go to Gij, when we go to G22, let me go to G22. If you go to the matrix that we have here, and you remove the row and column containing the element G22 here, this element here, you remove the second row and the second column, then you are left with the square matrix, a 2 by 2 matrix, and the determinant of that will be 1 times x1 sine of x2 squared, which is x1 sine of x2 squared. So now, when we write now G22, which is 1 alpha G times G22, this will give us 1 over x1 squared sine of, we have x1 sine x2 squared times x1 sine of x2 squared. And when we multiply, we see that we get 1 over x1 squared. This is the normalized cofactor G22. If we go to G33, we go to G33 and we look at our matrix again. We remove the row, the third row, the third column. We are left with this submatrix. The determinant will be x1 squared. So we get this is x1 squared, and the normalized cofactor G33 will be 1 over g times g33. So this will be 1 over x1 square times x1 sine of x2 square times x1 square. And when we work out this, what do we get? We get 1 over x1 sine x2 square. Now, because the other elements are 0, then obviously their cofactors will be 0. And so we will not need to work out all those, because we'll be getting 0, 0, 0 everywhere. Now, we want to consider a metric in V2, another example 2. I want to consider example 2. And consider a metric in V2 in 2 dimensions defined by ds squared is equals to dx1 square minus all of the plus 2 cosine of phi dx1 dx2 plus dx2 square. Now, because of the symmetry of the components of the metric, we can write this one as ds squared is equals to dx1 square plus cosine of phi dx1 dx2 plus cosine of phi dx1 dx2 plus dx2 square. So that the matrix G here will be 1 Gij, not G. It will be 1, then we have cosine of phi, then we have cosine of phi, and then we have 1. So that when we write, we can now write the cofactors. The cofactors G, or rather we can first find the determinant. The determinant small g. G will be 1. Remember, the determinant is obtained by taking the product of the elements in the leading diagonal minus the product of the other two. So we have 1 minus the square of cosine of phi. Using the trigonometric identities, we can write this one as the square of sine of phi. Now, this is the determinant. When we want to write the cofactors G11, the cofactor of G11 is this element. You remove the row, the first row, the first column, you're left with only one element, 1. So that should be 1. If we write G12, 12 is the element cosine of phi here, and we want the cofactor of this. If you remove the row and the column containing this, remove the first row, second column, you are left with cosine of phi. So we have cosine of phi. But when we are determining the cofactors of elements in a matrix, remember we usually have the place sign. So we get the determinant here, but multiply by the placement. So we have cosine of phi multiplied by the negative sign here, negative 1. So we get negative cosine of phi. If we write G 2, 1, we go back to the matrix. G 2, 1 is this element. So we remove the row and column containing this element. We are left with cosine of phi. We check the sign is minus 1. So we get minus cosine of phi. And lastly, we have G22. G22, you see we have element 1 here. We remove the row and column containing this element. The last row, the last column, we are left with an element 1. The sign is plus, so we get positive 1 as G22. So now, when we want to write the normalized cofactor, we have G11 is 1 over G times G, so this is small g, 1 over the determinant times G11. This is equals to 1 divided by the square of sine of phi. Because the determinant was the square of sine of phi here. If we write G21, then we get, which is equals to G12 here. We can work out them separately, but they are just the same. So we get minus cosine of phi divided by sine squared phi. Then we have G22, which is again 1 over G times G22. So this will be 1 over sine squared phi. So that we have these are the, so we did not need to work out G21 and G12 separately, but we could have written G12 is equals to 1 over G12, and this will be 1 all over the sine square phi times negative cosine of phi. This should give us what we have here. The same with G21. So this is how we can get these components, or these normalized cofactors. And I think I'll send you some more examples on this, but you can do them the same way. And I'll send you some notes on that and some more examples. Then you can go through them, and you can do them and practice on this, how to get these cofactors and how to get the normalized cofactors. So we shall continue from there in our next lesson.